So to perform this maneuver, we have to be familiar with what tachycardia cycle length actually represents. And when you measure the tachycardia cycle length, what this tachycardia cycle length is actually representing is the time it takes for one rotation of a reentrant circuit to occur. And this goes for all reentrant tachycardias, whether it be VT, atrial flutter, some form of SVT such as AVJRT or AVRT. The tachycardia cycle length is dictated by how long does it take for one cycle of reentry to take place. The post-pacing interval, in contrast, reflects the time it takes for the paced stimulus from your pacing catheter to travel to the circuit, go around the circuit, which will take a time equal to tachycardia cycle length, and then come back from the circuit to the catheter again. And so on an EGM, once we finish RV overdrive pacing, we see an intervening time period where nothing is happening. So during this time, we're getting pace stimulus traveling to the circuit, going around the circuit and starting to come back again, and nothing is happening. The RV electrode is too far away from all of that activity to sense anything. And then finally, we get an RV electrode EGM. And so this tells us that our depolarization wavefront has returned to the catheter again. And so if we remove the tachycardia cycle length from this post-pacing interval, we remove this part and we're left with how long did it take for our pace stimulus to go to the circuit and come back again. And we're left with some number. And if that number is more than 115 milliseconds, it says that our RV catheter is far away from the circuit and therefore in keeping with AVJRT. And if we get a number that's less than 115 milliseconds, this is in keeping with AVRT because it tells us that our RV catheter is fairly close to the tachycardia circuit. So in the context of AVJRT, all the post-pacing interval is how long does it take for our paced stimulus to go to the circuit, which in this case means traveling up the interventricular septum. And that's going to take some time. So let's say that takes 100 milliseconds. Let's be conservative. And on the EGMs, it will look like a period of isoelectric period. And then around the circuit, once we entrain tachycardia one last time, and we already said that it takes 300 milliseconds to go around the circuit because our tachycardia cycle length is 300 milliseconds. So we know this takes 300 milliseconds to complete. And after we entrain tachycardia, we'll get a depolarization wavefront that depolarizes the ventricles. And eventually it will depolarize the myocytes beneath the RV catheter. And so that will take some period of time as it travels down the interventricular septum in this case. So let's say 100 milliseconds once again. And our re-entry part would be this part of the isoelectric line. And once we get depolarization at this level of the RV catheter, that's when we'll first get our EGM. And so the post-pacing interval simply reflects how long does it take to go to the circuit, around the circuit, and back from the circuit to the catheter again. So we measure from the pace stimulus to the first electrical activity in the same electrode that you are pacing from. So if we add up all these numbers, our post-pacing interval in this case will be 500 milliseconds. And so the calculation here is to correct it for tachycardia cycle length. So if we minus our tachycardia cycle length, we're minusing 300 milliseconds at this point. And what we're essentially removing is this part of the pacing stimulus's journey. And from removing the tachycardia circuit from this equation, what we're left with is simply how long it takes for the pacing stimulus to get to the circuit and come back again. So that gives us some idea of how close the pacing catheter is to the circuit. So it doesn't necessarily have to be from the RV apex. you could put your catheter right on top of the circuit and you would get a post-pacing interval minus tachycardia cycle length of 0 milliseconds. But if you put the pacing catheter in the RV apex, during AVJRT, it just so happens that you'll get a PPI minus TCL of more than 115 milliseconds almost every day of the week. And this just means that the RV apex is quite far from an AVJRT circuit, so it always tends to be more than 115 milliseconds. In contrast to performing this maneuver during AVJRT, our calculation will look quite different in the context of orthodromic AVRT,